In this lab, we want to use SOLIDWORKS FlowExpress to analyze water flow through a globe valve. So let's look at setting this up. Open up the globe valve assembly, and if we look over here, there are only a couple of constraints in here. And so the first thing that we should do is make a copy of this before we start constraining it, in case we get lost about where some of the components go to. So I'll do a file save as, save that, and now make sure that I'm on the copy file. Alright, the inlet housing or this side is fixed, and the outlet housing on this side is fixed. Now we could go through the effort of constraining all of the fasteners, but this was an imported part from a step file, and so there is no history tree, and so it's unlikely that the parts are going to change any, so we may be safe in just fixing or grounding the location of these fasteners. And so I'm going to right click on each one of these fasteners, and I'll do fix on that one and so forth. I'll do fix on this one, and if you're sure which ones they are, if you take the time to find them in the browser, you could also just do this all in one step by selecting all of the fasteners. And so I'll fix that one, and I'll fix these fasteners over here on this side, and I'll hold down the control key and get more than one at a time. Alright, so I'll fix all of those fasteners, and I might want to put those into a folder, and so I'm going to select the first one, and I'll hold the shift key down, and I'll go down to the last one, and I'll right click, and I'm going to select add to new folder, and I'll call that folder fasteners. Now in reality, we might just remove these fasteners from the analysis altogether, because we're going to analyze fluid flow through the center of this valve, and we don't really need those fasteners for that purpose, but I'll go ahead and leave those in. And then this component right here would also be fixed into place, so I'll fix that one. And then I'm going to turn off the visibility of either this housing or this housing so that we can see inside of the assembly. So I will come up and I will hide that part. And what you might want to do is, if I expand this, so I can turn the visibility of parts on and off in this column now. And so I see I have this globe inside the stem that goes to the globe, and there's a washer. Okay, I'm going to drag this part out, and I will drag this part. Now keep in mind where this one is at so that we can put it back in that same location. And I'll drag this part, and if I try to drag the washer, that was constrained in position already, so we don't need to move that washer. If I move this part, we see that it moves out here, and the globe valve, and then this part. Now all of these parts have appropriate clearance between the parts, so you can't manufacture perfect parts, so we should include the clearance between the parts when we are making them. Because they have clearance, the most robust way of constraining these parts is by the origin planes of the parts. So I'm going to do mate, and I'm going to mate this face right here to the bottom of this stem, and so that stem would come against that face, and I'll apply that. But then to put this in the center, I'm not going to mate this face to this face or this face to this face, because there is clearance between this piece and the slot that it goes into, so I'm going to mate it in the center using the origin planes. So I'll drill down and find the stem, and I'll find the plane going through the center of the stem, and I'll find the plane going through the center of the globe. And so I need to go down and find the globe. I'll expand that, drill down, and I will select the front plane on that. We see that moves that over into position, and then I also need to do it from the right plane of the globe to the right plane of the stem to move that into position. So whenever possible, use the origin planes to constrain your parts together, and that implies whenever possible, when you're modeling your parts, model them with symmetry about the origin planes. And so now if I look at this from the right side view, and if we zoom in on this slot, we can see there's a little bit of clearance on this side, and there's a little bit of clearance on this side. Now probably this should have been modeled with a little bit of clearance between here and here as well, because it's going to bottom out either here or here when we assemble this, and we can't make perfect parts, so it's unlikely that it's going to be exactly perfect the way this one turned out to be. Okay, now the entire assembly was constrained about the origin, and I'm then going to constrain the stem to the center of this plate, or we could do it to the center of the housing, and we should probably do that to the housing. So I'm going to turn that back on for a moment, and then I'll do my mate. I'll select the cylinder on the stem, and I'll select the cylinder on the inlet housing, and I'll say OK to that. And then we have to decide how far up or down that should be, and let me turn off the visibility of the inlet housing again. And so we need to get this at its position up or down, and again we can use the origin planes to do that. So if I find the top plane of the assembly and I mate that to the top plane of the globe, and so there's the top plane of the globe and the top plane of the assembly, it'll move that into position. And also, if I turn off the visibility of the O-ring, we see that this part went up into there. And if we do a section view of this, I'll do a section view on the right side plane, we see that that part fits up into here, and then the seal went underneath that. If I try to move this, if I test it out, we see now that it has 1 degree of freedom, a rotational degree of freedom. Okay, then I'm going to constrain this part and this part, and so I will do mate, and we know that it will be centered between here and here, and I'll apply that. I'll move this forward some, and then I'm going to constrain it with this face against that face. So I'll do mate, and I'll select this face, and I'll select this face, and I'll select OK to that. Now I want to make sure that there's no clearance here where fluid could leak around this seal. So I'll go back to section view and look at this in the section view, and we see that this seal is up against the globe valve right here, but notice there is clearance over here where the globe can rotate. And again, we can't make perfect parts, so the globe was made a little bit smaller than the housing. Otherwise the friction would be too great for this to rotate, but there's a low coefficient of friction between the globe and this seal, so we could rotate the globe. And if we turn on the visibility of the rubber gasket so that we can see it, there is no clearance up here either, or there's no gap here where fluid could leak out of here. So there's a seal here against the stem, and there's a seal on this side. We now need to place the seal on the other side. So I'm going to hide the outlet housing, and I'll make visible the inlet housing, and then I will do mate, between this cylindrical face and this cylindrical face of the outlet housing, and then I will do a mate between this face and this face, and we'll say okay to that, and we'll look at this, and so now we see that there is a seal from here to here and up against the stem on this side. I will turn the visibility of my parts back on, and I'll leave section view. Actually, let's go back to section view for just a minute. So if we rotate the stem, we see how that hole in the globe rotates around to allow more or less fluid to flow through. So when it's fully open, the fluid can flow through unobstructed, and then when it's partially closed one way or another, that reduces the amount of fluid flow, and if we turn it full 90 degrees, there is no fluid flow at all. Let's look at it from the side. So again, that opening decreases until we have no fluid flow. Now there may be a little bit of leakage around this because there's clearance between the globe and the housings, but the seal is uptight. The seal is actually compressed, made of material that can be compressed when everything is assembled together. Right now I'll leave the section view. Then I'm going to put this part onto here. I'll do mate. I'll select the top of this part. I'll select the bottom of that part. That mates those together. And then I need to find those two parts over in the browser. So this is our lock. I'm going to expand our lock, and then this part is our stem flange. I'll expand this stem flange, and then I will do constrain or mate the front plane of the stem to the front plane of the lock. So that moves that over, and then the right side plane of the lock to the right side plane of the stem, and that moves it into position. So notice that I didn't just use one of these faces mated to this face, because again there is clearance between all of these parts so that they will go together. So there's a little bit of clearance between here and here, so that centers it by using the origin planes. And then I'll do the same thing with the handle. So I'll do mate the bottom of this handle to the top of the lock, and then I will find the handle, drill down, and I will mate the front plane of the stem to the front plane of the handle. That moves it over in position in that direction. Then I'll do the right side to the right side, and then if I test this out, and it's not moving, so somehow I must have gotten a lock on there. So I'll expand all my constraints. When I go to test it, it doesn't move, so I know I have a constraint that is incorrect. And so if I go down through my constraints, so this was the lock to the stem, and then the lock to the handle, that's the bottom of the handle to the top of the lock. And then I have stem flange to the handle, that's incorrect. So the stem flange is this part, that doesn't move. So I need to delete this one and put it in correctly. And so I'll delete that one, and then I have the lock to the handle. I prefer to have that as the stem to the handle, so I'm going to delete that one and put that one in again. All right, so I'll expand these, and so here is the stem, and close down the stem flange, and here is the lock. And so I'll do mate the front plane of the lock. I need to get the handle, so close down the lock, and so here is the handle. I'll do the front plane of the handle to the front plane of the stem, and then the right side plane of the stem to the right side plane of the handle. Right now I'll test it out again. So if I move this, we see the lock and the handle and the stem, and down inside there the globe all move together. So those are the moving parts. So really we can go ahead and fix in place all of the gaskets, and so that part doesn't move and the seals don't move. so I could fix those into place. Here's the second seal, and we've had them constrained in place anyway, so we really didn't need to fix those locations, but that just assures that we don't accidentally move something. Alright, now I want to put this in a particular location, and let's say that I want this to be when this is full open. So this is our inlet, this is our outlet, and I want it when it's full open, I want that plane going through the center of the handle to be at an angle to the plane going through the center of the assembly. Let's move that off a little bit. So I'll find the plane going through the stem or the handle. Let's do it through the handle. I'm going to mate the front plane of the assembly to the handle front plane. But I want to do this as an angle, so I'm going to put in angle here, and let's see what it does if I put in 0 degrees. And so I'll do 0 and hit tab, and it goes the opposite direction, so I'm going to tell it flip dimension, and that didn't do it. I'll flip alignment, and so that put it around, so 0 degrees is at that position. Now that will allow me to move that. Then if I want to change that angle, let's say to 30 degrees, I can set how much, and I want to do that, let's say negative 30 degrees. I'll flip that dimension. Okay, so I've opened it up or closed it down by 30 degrees, and I can set whatever angle in here then that I want for that opening. Right, then we need to create some lids on here for the analysis, and I'm going to create a configuration for that. And so I'm going to add a derived configuration from the original, and I'm going to call this a flow analysis. So now I see that my flow analysis is the current configuration, and then I'll start a new part on this face, and I'm going to convert entities this edge, and then I'm going to extrude that. So I'll go to features, I'll do extrude, and I'm going to flip that direction, and I just want to put that into a minor amount, so let's do 1 millimeter on this one. Alright, so I created a lid on this end. Let's go back to this part, and I never gave it a name, and so let's go ahead and do save. Give it a name. I'm going to call this inlet lid, and then I was just making sure that I put it on the inlet side, so I put the lid on the inlet side, and I will click the confirmation corner to get out of editing that part, and then I'll select new part, and I'll select this face, and I'll convert entities, select that circle, I'll go to features tab, I'll extrude this, and I want to flip that direction going back into the housing 1 millimeter. I'll say okay to that. I'm going to this outlet lid, and I'll select my confirmation. Okay, so I have a lid on the outlet, and I have a lid on the inlet. We may want to turn off the visibility of some of these components, so I'm going to hide the inlet housing and the outlet housing. So what we're trying to do is find the fluid flow as it goes through there. And so we'll go to Tools, and we'll do Express Products, we'll do FlowExpress. We're given a message that we should have lids, which we do, so I'll click next, and I want to see that there is an enclosed area in between this lid and this lid. So if we do view fluid flow, we can see that here's where the fluid, it goes through here and it goes through here. What we want to make sure is it doesn't come up through here, and that would indicate a leak somewhere up in this area. So this is the area where the fluid is going to flow. This area right in here, this is real thin, and it's real thin right in here. That's that tiny amount of clearance between our globe and the housings. I'll click next. We'll tell it we're using water as our fluid. I'll do next. I'm going to set on mass flow rate, and for our inlet I will select this lid. Notice it gives you a tooltip letting you know which one that is, or so you make sure you get the correct one. I'll select the inside face, and then I'm going to set this as 0.5 kilograms per second, and we'll leave it at the default temperature. We'll go to next, and I'm going to set this face as my outlet face, and I'll leave that at the default pressure. It's open to the atmosphere on the outlet. I'll do next. Now I almost hit the OK there. If you do hit the OK, you can always get back to where you were. So I'll go ahead and save it while I'm here. It's asking me whether I want to save the lids internally in the assembly or externally. For this, it doesn't really matter. I'm going to tell it externally though. And then I'll go back to my tools, FlowExpress, and I'll tell it to solve. Okay, so we can see the trajectory of our fluid and the velocity, and we can increase or decrease the number of pipes, or we can put the fluid flow represented as balls, and we can animate that flow so we can see how that flow goes through the valve and speeds up as it comes through that restricted area. Let's change it to balls and look at the same thing. So I'll stop it, I'll put it on balls, and we can again see how that fluid is flowing through our valve. We might want to turn on the visibility of the housing and turn off the visibility of the lids. And so I'm going to go to the lids, and I'll hide that lid, and I'll hide this lid. And let's actually leave the analysis for a minute, and I'll turn on the visibility of the inlet and outlet, but I'm going to make those transparent. So I'll click here to make it transparent so I can still see it. I'll go to the outlet housing, and so I've made that transparent. And you might want to change the amount of transparency so that you see it more clearly. And let's go ahead and go back to Tools, FlowExpress, and we will put it back on pipes and flow again. Now, I might want to change the globe itself to be transparent so that I can see around the globe. Alright, let's close this down. Instead of 30 degrees, let's close it down to 45 degrees. So I'm going to finish this analysis. I will go back to my configurations, and I'm going to create a derived configuration from the previous one, and I'm going to name this one 45 degrees. And then I'm going to change the constraint for this one, the angle constraint. Let's change that to 45 degrees. And let's make sure we still have an opening through there at 45 degrees. Okay, so I've almost closed it off. I have a little bit of an opening there. And then we can run the simulation again. So the first one we ran at 30 degrees. This one we closed it down to 45 degrees. And I'll go to Tools, FlowExpress. We made a change, so we have to solve it again. I'll hide these outlets or make them transparent in this configuration as well. So I will go back here and make that inlet and the outlet transparent. So I have the outlet transparent. I'm having trouble making the inlet transparent. There we go. And then we'll go back to our tools, and we'll go to FlowExpress, and we'll play the, so this is with it closed down to 45. We can see the turbulence caused by closing this down. There's more turbulence now inside that globe. We can see through that. Why it's playing it, it actually shows us through the globe. Let's play it again.